Hey everyone, thank you for coming to the talk and welcome to B-Sides. This is my first time ever talking in front of a podium, so I'm pretty nervous. I'm so, please forgive me if anything, if I fall down or just faint up. Thank you so much for attending the talk. Today we'll be talking about OAuth and OIDC, how it works under the hood, and we'll see different OAuth flows. Before we begin, let's do a quick intro about myself. My name is Prabesh. I am currently working as a senior SRE at Capsule, and my work revolves around backend infrastructure and security. I have good knack for it, more interest in security. So, and I'm also a Docker captain. So today we'll be going through a couple of things. In order to know more about OAuth and OIDC, we need to know a couple of underlying details or terminologies. So we'll talk about a little bit about digital identity. We'll talk about encryption, authentication, and authorization. We'll talk about tokens and the different types, and then we'll go into OAuth, how it works, and how it fits into with OIDC, and we'll go through some recommendation and security consideration at the last. And I'll hope we will do a couple of Q&As, and that's all for this talk. So let's begin. So before we begin, right, in physical world, we have our physical identity with us. We have our facial structure. We have our eyes, blue eyes, black hair, and all those different physical attributes that we use to identify each other in the physical world. Similar to that, anything that we use to identify ourselves in digital world is known as digital identity. I think we all are aware of it. Example would be our unique username, our email address, our biometric data, digital certificates. So all of those are the one that we use to identify ourselves in digital world, and also are called digital identity. Let's talk a little bit about hashing and encrypting, because we'll go through it throughout a lot through this talk. Hashing is basically converting a plain text into a fixed length character called hash, and most of the time we use hashing to check the data integrity, whether it has been tampered or not. And the result of hashing is a fixed length. Depending on the algorithm that we use, it results in a fixed length gibberish character, right? Compared to encryption, encryption converts plain text into a ciphertext using different algorithms, and unlike hashing, it doesn't result in fixed length output. It can be of variable length. So the key difference between hashing and encryption is you could decrypt the value to get the original value while encrypting, or it's a two-way process, while hashing is a one-way process. Even if you see some website where it says it is decrypting, it is trying to compare the two hash of two values, not actually reversing the hash. So it's a one-way process. So let's do a quick question. I think it's too early, but yeah, it's good. Can any so we have all used bcrypt and base64, right? Please raise your hand if anybody thinks bcrypt is hashing or encrypting. So is it hashing or is it encrypting? Yes. So you know, bcrypt it's a hashing technique. We don't encrypt the data. So same for base64. How many of us thinks base64 is hashing?
The governor of Wisconsin.
Sorry?
The governor of Wisconsin.
How about encrypting? Is base64 encrypting? No, right? So base64 is neither of those. It's actually encoding. So there is a difference. Encoding does not add security to the value, unlike hashing and encrypting. So these things needs to be considered. Let's talk a little bit about authentication and authorization. I think we are on an InfoSec talk and everybody is pretty aware of those, but let's quickly go through it. Authentication is basically verifying who you are claiming to be, and authorization is more towards, do you have access to view or interact with particular resource, protected resource. So those two are two different things. Now, one more thing that we need to discuss before we delve into OAuth is tokens. Tokens are basically short, like carefully crafted mathematical, like it's a random string, but it's not random as in it's created with good algorithms, but yeah, basically it's used to either verify user identity or provide access to certain resource. Like similar to if we go in different like DMV, right? They give you unique token to which you show it to the clerk or anybody sitting there and to validate. Sometimes we use it to validate our identity, sometimes we use it to provide access or get access to certain things. So nowadays, like there are a couple of different type of tokens you would see in the internet. There are different types are access token, refresh token, session token, ID token, and CSRF token. So access token is basically, this token is used to provide you with particular access to protected resource. That's it, not authentication. And refresh token is if your access token expires, you need some way to regenerate the access token, right? That is why we use refresh token. And there is another called session token. Session token is when you are logged into a website, you browse into different pages, you need to make sure you are not prompted to log in every single time. So session token are used to maintain a session. Most of the time we use cookie, like store it in cookie. And there is another type of token called ID token. ID token, unlike access token, is used to verify our identity. So it contains user information built into the token itself. And there are other tokens like CSRF token, which is used to make sure like our data or request is not forged in any shape or format. So these are the widely used tokens. You will find other tokens in the internet running around, but these are the most common used tokens in the internet. So now we know some basics or like terminologies of which we need for OAuth. Let's talk about OAuth. OAuth is a open like standard authorization framework. Like people get confused with OAuth as authentication, but it is indeed it is in fact authorization framework. It is used to verify whether a person or entity has access to particular resource or not. It doesn't in no way or shape or format validate the identity of the user. So something to be careful about. And it helps, like OAuth is used to delegate permission to, like suppose I am using an app and that app needs to access my GitHub profile or my profile information stored in like Facebook or GitHub or LinkedIn, then we delegate the permission to that app to view that resource on my behalf. And also OAuth is pronounced as I said, OAuth, and it's not same as Auth0. Auth0 is a product by Okta, whereas OAuth is an authorization framework. And so OAuth comes with, like in the framework itself, each entity is assigned a particular role. The role is differentiated based on the permission and the responsibility they have. And there are different, like 4 type of roles. Let's go through each and one of them. So resource owner is somebody who owns the resource. So I am the resource owner for all the data or information in my GitHub profile. And resource owner like owns the data in the resource server, and it, like most of the time, resource owner is also referred to as end user. So basically I am resource owner for anything in the internet which belongs to me. So there is another thing called resource server or RS. Resource server is the server that hosts the protected resource. So if my GitHub has all my information, right? GitHub is the resource server for my GitHub, like all the GitHub codes, my profile, my email information. And resource server are capable of accepting the request and responding with certain resource. Suppose I request GitHub server to give me all my profile information. I will send the request to GitHub resource server, and it will send the response back with all the resource. But in order to get that, I need to have access token, as I mentioned there before. Client. Client is a bit like, so it's a application that wants to access resource, protected resource that is sitting on resource server. Sometime the resource server and the resource server and client might be of different app. Example would be, suppose if you build a OAuth app and it needs to log in using Google. Now that client needs to get profile information from Google's resource server to provide it needs to talk with Google's resource server, then that app itself is called client. And it's a bit controversial as well. So if you think of it in such a way that server client architecture, if somebody says like, if I am requesting some detail with the application, I am the client and the application is the server, right? But in OAuth, application itself, which tries to access the resource sitting on resource server, is the client. So just to clear the confusion, whenever we mention client in this talk, it's the actual application or web app running which wants to access some protected resource. And there is something called authorization server or AS. Basically, the role of authorization server is to issue access token. So I or resource owner initiate or clients request the authorization server to generate access token for me, and it is responsible for getting the request from the resource owner and generating an access token. But before generating the access token, authorization server also requests for something called consent. Consent is basically end user, me, saying I consent to this activity. So whenever you log in or whenever Google's, you log in with Google on certain app, it says you, do you want to allow this operation on the application? So that is the consent screen. And once all the process is done, authorization server issues an access token, then that access token can be taken to the resource server and fetch the protected resource. So there are other terminologies as well. You'll hear a lot in OAuth. One is authorization request. It's the request that, as I said, client send a request to authorization server, right? It's a request that is sent by client with various parameters. We'll see it in a minute to authorization server, and it is approved by resource owner. There is another thing called resource grant as well. So resource grant is after resource owner or authorization, resource owner grants the request to the authorization server to provide access, it grants you with the permission and a code. So basically authorization grant is that grant. There is another thing called redirect URI. Redirect URI is basically once, when somebody tries to access the protected resource on resource server, it needs to get the consent and also redirect user back to the original app URL, right? This is the redirect URL. They are also known as callback URL, where user needs to be redirected after all the consent has been given. The other thing is scope. Scope is basically limiting what level of access a person or a client can get when doing the OAuth dance. Consent, as I said, is an approval process where somebody where authorization server requests or resource owner to actually do you want to give this person access to this resource? So let's see how OAuth works in general. So we have a client. What happens is client first initiates authorization request to resource owner. Now once everything is validated by resource owner, it responds back with an authorization grant, and that grant contains a code, actual code called authorization code. We'll talk about it more. And client then uses that code and sends another request to authorization server now. And after the code is validated and verified, authorization server responds back with access token, and that access token now the client can use to access the protected resource in the resource server. Sometimes authorization server and resource server can be on the same server as well. It doesn't have to be different. So once client sends the request with access token, it responds back with actual details requesting from the protected resource. So the thing that we just saw now, it's called an OAuth flow. There are different kind of flows. So flow is basically a series of steps or dance that client needs to do to obtain access to the protected resource. That's it. Like, it's basically some like fancy dance move you need to do to access the resource. There are different flows, authorization code grant flow. There are like auth code with PKC. We'll go through each of them. Implicit flow, resource owner password grant flow, and there is like something called client credential flow as well. So let's look into each of them. I'm not sure if it's visible or not, but I'll try to explain. So authorization code grant flow. Basically, in this type of flow, what application does is client redirects the resource owner to authorization server endpoint, and then after like the redirection and validation is done, RO, like resource owner as a user, consents to that operation and then authorizes the access request. After that is done, authorization server responds back with authorization code, and then client can use that code to actually access the authorized, like a protected resource. So we also talked about it before. That flow, or this type of flow, is called authorization code grant flow, or it's also called three-legged flow. Let's see how it works in code. When client redirects to authorization server endpoint, it adds certain parameter as part of the query param. So the thing that you see there is called response type equals code. That is where you specify what type of flow that you want to use. And the second is client ID. Client generates its own unique client ID and send it to the server. And we also need, as we discussed, we also need to send the callback URL or redirect URI, where after everything is done and consent is approved, this is the URL authorization server would redirect the user back to. Scope is, as we discussed, certain limited permission. We only want the access token, like whenever we return back the access token to the client, we don't want to give them all the permission, right? We want to limit it to certain particular level. So with this request, client will be only allowed to create and delete the resource. You could tune it down to profile information only, but yeah. And state is make sure, like we are trying to make sure none of the data is tampered in between. Or like when request is sent and we receive the authorization code, nothing was changed. Now, once we send the request over, what happens is authorization server now responds back with like this, like as you can see the URL, right? This is the same URL that we passed in as part of the redirect URL, and along with that, now authorization server adds some values in the query param, which one of which is code. That is the actual authorization code, and now client uses that code and sends the request to actual authorization server to generate access code. Now we can see grant type, we are using authorization code, and grant type is also flow type, like don't get confused. Basically it's a grant, like grant, flow, steps, like they all mean the same. And there is a client ID. Client generates its own secret and sends it to the server. And again, we send the authorized redirect URI, and the last thing we send is the code that we just received. This is all done by client right now. Once we send the request, authorization server validates the authorization code, validates the state, validates the client ID, and then after everything is verified, it generates the access token with expiry. So you can see it responded with token type, it's a bearer token, it responded with certain expiration time, it responded with access token, which is what client would need to use to communicate with resource server to fetch protected resource. We tuned down the scope as well. These are from different examples, so the scope is different, but as you can infer, basically we are trying to limit down the permission to particular resource only. And it also responds back with refresh token, as we discussed. In case when access token expire, client can use this refresh token and send it to the authorization server again to generate a new access token. This is also called silent reauth. Now the other thing, like another OAuth flow that we would need to talk about is OAuth code, like authorization code grant flow with PKC. So everything is same, but with PKC we add a couple of extra steps to verify none of the requests was tampered in between. with like, so what happens is client generates the code verifier and then generates a code challenge. Now both of them are like random string which is encrypted using SHA-256, and then that code is sent along with original OAuth request or original authorization request to the resource server, sorry, authorization server. So as you can see, everything is same. The only thing that we are sending extra is we are sending the code challenge value and also the method. Now like authorization server validates the request and responds back with code verifier as well. So both the resource like client and authorization server will keep those two values to make sure none of the interaction or like we are not basically protecting ourselves from man in the middle attack. There is another flow called implicit flow. Unlike authorization code grant flow where we send the request to authorization server, it sends like resource server, it sends request back with actual like code, authorization code, and then we use the code to generate access token. In this case, client redirects the request to authorization server, and authorization server once validated, it directly responds back with access token. There is no authorization code in between. Now the problem with this approach is it responds back in the access token in the query param as well. So there are like you can see there are other like a lot of issues with this as well, right? If you are responding as part of the query param, there is high chance the value might be stored in like browser history or anywhere. So this is not recommended, but for the sake of going through all the flows where we are discussing about it, if you try to avoid using implicit flow as much as you can, because safety wise it's not good. Now other flow that we could talk about is resource owner password credential flow or ROPC. So basically what it does is, suppose your resource owner or authorization server doesn't, like it's a legacy product or legacy system and doesn't know how to talk with OAuth. You only have username password. So in this case we use resource owner password credential where client directly sends the username and password to authorization server, and that authorization server validates the credential and then responds back with access token. Yeah. So the another flow that we are talking about is client credential flow. Basically in client credential flow, client sends its own credential to authorization server directly, and authorization server verifies the credential, validates, and then issues access token directly to the client. The difference between this and ROPC is end user is not involved in here. It's client stores its credential locally on their machine. So suppose if you had two microservices trying to communicate with each other using OAuth, you would use client credential flow. So yeah, we went through OAuth, we went through all the terminologies of OAuth, we went through all the flows of OAuth. Now let's talk about OIDC or OpenID Connect. OpenID Connect is an authentication protocol that is built on top of OAuth. So like they are not different, it's just OAuth is the framework on top of which OIDC is built upon. It adds like OAuth, as we discussed, OAuth gives you authorization or access, whereas OIDC it adds authentication on top of it. So yeah, identity layer on top of it, and whenever you see ID token being circulating around, you can be assured like it's using OIDC under the hood, and yeah, OIDC uses OIDC uses ID token, and most of the time we use JWT, but there are other ways, like there is no mandatory hard and fast rule to use ID like JWT. You could use opaque token or any kind, like nowadays Pesto is getting more popularity as well, so it depends on the company how you want to roll it out. But yeah, so how, like we already have seen this diagram, right? It's a general OAuth flow. The only difference is when everything is sent back to authorization server with authorization grant, instead of just responding with access token, authorization server again responds with ID token as well, and that ID token contains users information. So same we send the request, OAuth authorization code grant flow or OAuth flow, and send the request. And the only difference now with normal OAuth request and OIDC request is we add OpenID as part of the scope. Basically, adding this effectively makes this a OIDC request. And after that, everything is the same. We do the OAuth dance, and at the end, we are returned with ID token. Now, client can use that ID token to get different information like issuers, who like, or scope of it. Everything is like, as you can see, ID token is also, if you are using JWT, it is separated into 3 fields. One is the header. I'm not sure if it's visible, but those 3 gibberish value are divided by a dot, and the first one is the header, last one is the signature, and the middle one is the payload. You could just copy this and go to JWT debugger and paste it, and you should be able to see all the information. So the next question people might have is, when should I use OIDC and when should I use OAuth? It's simple. If you want to authenticate somebody, use OIDC. If you want to authorize somebody, use OAuth only. So OIDC is like ideal for a scenario where authentication is your primary concern. Suppose I created an app that needs to communicate with, I created an app which uses OAuth and communicates with Google server. You would need to send OpenID requests to authenticate, because when in application that says like continue with Google or sign in with Google, it needs to verify the identity of the user as well. So in such case, you would send OAuth request, but you would also add OIDC as part of the scope and make it effectively OIDC request. You use OAuth 2 for authorization, basically trying to grant some user permission to protected resource. And also a lot of time OAuth is used to delegate authorization. You instead of you doing it yourself, you ask some third-party app to authorize on behalf of yourself. So let's go through some recommendation. If you are using a app which wants to use OAuth or sign in using social, you just use OAuth authorization code grant flow or OAuth authorization code grant flow with PKC. If it's a server-to-server interaction or API-to-API interaction, you would use client credential flow, because client can. Having said that, if you are using client credential flow, client needs to store the credential itself. So we need to make sure client has stores the secrets or credentials safely. And if you are using mobile app, authorization code grant with PKC is good enough, and same for SPA. And if you are using CLI apps or daemons, you don't need to interact with each other. That daemon needs to automatically communicate with your OAuth server or authorization server. You would use client credential flow. And for legacy application where you are where OAuth is not built upon or it's not supported, you would use resource owner, where you actually pass in the username password. So couple of security consideration is client authentication, right? There is high chance when we send requests to client, a client sends request over to the authorization server or resource server, it could be intercepted with you using man-in-the-middle attack. So what we need to make sure is everything is encrypted using at rest and at transit using MPLS or TLS. And as we said, PKC, if you add PKC with authorization code grant flow, you would address the concern, you would address the issues where somebody tries to impersonate as a client and try to access protected resource from the resource server. And if you are using access token or refresh token, make sure you are storing it securely. Maybe use HMAC or any kind of a bit more one-way encrypted, one-way hashing protocol, and make sure they are expiring at limited. They are only issued for short period of time. Generally, access token expires within the session of the user, and refresh token are a bit longer, around 24 hours, depends on the company. We need to make sure attacker can't use the credential guessing attack. So in order to do that, we would need to make sure implement some kind of security measure where where people can't guess the attack. Maybe make it longer or make it more complex, use a bit complicated protocol algorithm. We also don't want to make sure people can run phishing attack or CSRF attack. So as we discussed, we are sending the state value and the PKC verifier value. This would protect you from CSRF and phishing. We need to make sure all the requests coming in and out and on the redirection URL are also validated and are defined as part of the course. So yeah, I think we are at the end of the talk. It was so fast. So before we leave, there are a couple of things that we need to like. If you don't remember anything, just remember like key takeaway with this talk would be this thing. OIDC is a protocol and OAuth 2 is a framework. OIDC is built on top of OAuth, and OIDC is used for authentication, and OAuth is used for authorization. And when you are in doubt which OAuth flow to use, just use OAuth authorization code grant flow with PKC. Do not treat ID token as same as access token, because it's your implementation. How it's like OAuth is a framework, but implementation it depends on company to company. Some people or some company uses hybrid flow. So do not try to use ID token with access token. They are completely different. And at least but the least, just use your best judgment. Ask your friends, peers, and that's it. If anybody has any questions.
All right, let's thank our speaker.
Hi.
I'm here for questions.
Can you explain a few key differences between the OAuth and OAuth and SAML?
Oh yeah, so SAML is like, obviously SAML is also used for SSO, and SAML was pre-2010 era where company didn't had option where like OAuth framework or tech behind it. So you would use assertions and XMLs and send the credential over. So SAML is still relevant. Like if you go to bank or legacy system that doesn't support OAuth framework, they still use SAML. But best practice would be to use OAuth, and the key difference, like main difference is SAML is hard. Like it's hard, it's complicated. There are different places you could make it go, like it could go wrong, and it was like it's good for legacy systems and tech, but if you are using new systems or building new app or new tech from grounds up, try to integrate it with OAuth, and that should be good enough. So only legacy systems. The difference is you use it for legacy systems. Yeah, that's all. So these are the references. I've left the link to the playground, which you could go and have a play, and they have good tutorials as well. And thank you so much. This was one of my first talk where I stood in the podium and spoke, so I'm pretty nervous. Thank you so much for listening through, and I hope you could take some information with you. Feel free to connect, and we'll like enjoy the rest of the conference. Thank you.